Earlier in the course, we talked about the main objective of a manager being maximizing shareholder wealth. How does the manager go about achieving this? This requires a manager to select projects that add to shareholder wealth. But usually there are a large number of projects to choose from. Further, the manager does not have unlimited access to capital. So there are constraints on how much capital she has for investments. Given the potentially large number of projects to choose from and the limited amount of capital available at the manager's disposal, how does she decide which projects to invest in? This is the area of capital budgeting. Starting with this video, we will look at a number of decision tools that managers may use to identify profitable investment opportunities. The first of which is the net present value, NPV in short. We will see how to calculate the NPV and how to interpret the NPV, which forms the basis for accepting or rejecting a project. Let's start off by seeing how to calculate the NPV of a project. As the name suggests, we have to calculate the present value of a series of cash flows, including some negative ones, to determine the NPV of a project. Let's start with a simple example to illustrate how to calculate NPV. Let's say that a project requires an initial investment of $1 million today. This investment will in turn generate cash flows of $200,000 a year for the next 9 years, which is the end of the project's useful life. Assume that the cash flows are realized at the end of each year. The appropriate discount rate for this project is 15%. To calculate the NPV of this project, we need to discount all cash flows back to today using a discount rate of 15% and then add them all up, including today's investment of $1 million. The NPV of this project is hence minus $1 million plus 200,000 divided by 1 plus 0.15 raised to the power of 1 plus 200,000 divided by 1 plus 0.15 raised to the power of 2 plus so on until 200,000 divided by 1 plus 0.15 raised to the power of 9. Ignoring the initial investment of $1 million, the annual cash flows of $200,000 form a 9-payment ordinary annuity. We can use the formula we saw earlier to calculate the present value of this ordinary annuity. Alternatively, we can use the PV function in Excel to calculate the present value of the ordinary annuity. The first input is the discount rate, which is entered as a decimal number 0.15. The second input is the number of payments, which is 9 for this ordinary annuity. The third input is the amount of each payment, which is $200,000. The final two inputs to the PV formula are not relevant here, and so we can ignore them. The PV function returns a value of $954,316.78, which is the present value of annual inflows of $200,000 for the next 9 years. To get the NPV of this project, we need to subtract the initial investment of $1 million from the present value of $954,316.78. We do not have to discount the initial investment as it is already measured in present value terms. Subtracting the $1 million from $954,316.78 gives us an NPV of negative $45,683.22. So what does this number mean? Note, we will always denote cash inflows with a positive sign and cash outflows with a negative sign. In this example, since the NPV is negative, it is telling us that the present value of outflows are greater than the present value of inflows generated from the project. That is, we do not recover our initial investment of $1 million from the project. Hence, our decision would be to reject the project. The NPV specifically tells us how much additional shareholder wealth is created or destroyed by the project. Here, the negative NPV tells us that if the company were to accept the project, shareholder wealth would reduce by $45,683.22. This is inconsistent with the manager's objective of maximizing shareholder wealth, and hence the project is rejected. A general formula for NPV is the present value of inflows minus the present value of outflows. Inflows are benefits, outflows are costs. If the NPV is positive, then benefits are greater than costs and we will have a positive NPV. This means that the project adds to shareholder wealth and hence must be accepted. On the other hand, having a negative NPV means costs outweigh the benefits and the project reduces shareholder wealth and hence it must be rejected. In summary, accept positive NPV projects and reject negative NPV projects. You are indifferent between accepting and rejecting a project if NPV equals 0, as it neither increases nor decreases shareholder wealth. Next time, we will look at the second type of investment decision rule, namely the internal rate of return.